All right, welcome. Today we're diving into what is essentially a clinical lecture, all based on the fantastic work of Assistant Professor Dr. Farhad Mustafa Atrashi. And we're going to start by challenging an idea you probably have about your own body. See, when you think of your skeleton, you probably picture a dry, static, kind of boring frame, right? Just a scaffold. Well, what if I told you it's actually one of the most dynamic, living tissues you have? Let's get into it.
You want proof? Okay, let's start with this wild fact. Every single week, your body replaces between 5 and 7% of its entire bone mass. Think about that. That is not the behavior of some static object. That is the sign of a living, breathing system that is constantly rebuilding itself.
So, here's the game plan for this explainer. We'll kick things off by understanding what this living framework actually does. Then we'll look at the building blocks, take a quick tour of its amazing architecture, and finally, wrap up by exploring how it maintains itself for your entire life.
Okay, first things first, let's really get a handle on what this architectural blueprint is designed for, because trust me, it's about so much more than just holding you upright.
It turns out our skeleton is juggling 6 core jobs. Support. Yeah, that's the obvious one. It's our frame. It also provides the levers for movement. And of course, there's protection for super important stuff like our brain and organs. But it's also a massive mineral storage bank. We're talking 99% of our body's calcium. Fifth is hemopoiesis, which is just a fancy word for making blood cells. And believe it or not, it even helps with detoxification by grabbing heavy metals out of our blood. It's a true workhorse.
So, what are the actual materials used in this incredible structure? Let's take a look at the building blocks themselves.
Now here's something that might surprise you. You were actually born with more bones than you have right now. You started out with around 270, but as you grow up, a bunch of them fuse together, bringing that final adult count down to about 206.
And those 206 bones come in 4 main shapes. You've got long bones, like the femur in your leg, that act as levers. Then there are short bones, kind of cube-shaped, like the ones in your wrist. Flat bones, like your ribs, are like thin shields made for protection. And then you have the wonderfully weird, irregular bones, like your vertebrae.
Okay, let's zoom in a bit on a classic long bone. See that long central shaft? That's called the diaphysis. And the 2 ends? Those are the epiphyses. This is our blueprint at the big picture level. But what's really going on inside?
Well, inside that hard outer shell of compact bone, you'll find spongy bone, which is a lighter tissue that looks almost like a honeycomb. And this is where the marrow lives. You've got red marrow, which is the factory that churns out our blood cells, and yellow marrow, which is mostly just for fat storage.
Now let's zoom in all the way, down to the microscopic level. This is where it gets really cool. What you're seeing is the fundamental unit of compact bone. It's called a Haversian system. Right at the center of all those rings is a little canal for blood vessels and nerves. This tiny, intricate network is what keeps our so-called non-living skeleton very, very much alive. All right, we know the materials, so let's take a quick architectural tour and check out some of the skeleton's most brilliant designs.
You know, bones aren't just smooth blocks. They're covered in all these markings, bumps, grooves, holes, and they all have a purpose. Take a foramen, for example. It's basically just a hole that serves as a perfect little passageway for nerves and blood vessels to run through. Every single detail is intentional.
From an architectural standpoint, the skeleton is split into 2 main parts. You have the axial skeleton right down the middle, that's your protective core, the skull, your vertebrae, and the ribcage. And then you have the appendicular skeleton, which is everything else, your arms, your legs, and the girdles that attach them to that central axis.
And for a little bit of fun trivia, let's talk about the hyoid bone in your neck. This thing is the ultimate loner. It's the only major bone in your entire body that doesn't directly connect to any other bone. It just floats, suspended by muscles and ligaments, and acts as an anchor for your tongue. How cool is that?
And all of this brings us to our final and honestly most important section, the lifelong maintenance that proves, without a doubt, that our skeleton is a living, adaptable structure.
So if you remember one thing, make it this. The skeleton you have today is not the same one you had 7 years ago. The entire thing gets replaced through this constant process called remodeling. You are literally always building a new version of yourself, bone by bone.
This remodeling is done by a little 2-part crew. On one side, you have the osteoblasts. Think of them as the builders, laying down new bone tissue. And on the other side, you have osteoclasts, the demolition crew, responsible for breaking down and absorbing old, worn-out bone. It's this perfect, continuous cycle of renewal.
And you can see this living process in action anytime a bone heals.
If you fracture a bone, your body immediately forms a clot. Then it builds a soft cartilage patch, which gets slowly replaced by a hard, bony callus. And finally, that same remodeling crew comes in to reshape it back to its original form. It's amazing.
But what happens when that perfect balance gets thrown off? Well, that's what happens in osteoporosis. The demolition crew, the osteoclasts, starts working way faster than the builders. So bone gets broken down faster than it can be replaced, and that's what leads to weak, brittle bones.
And this is a really serious issue. By the time the average white woman turns 70, she's lost 30% of her bone mass. In some people, it's as high as 50%. This number just highlights how incredibly important it is to maintain that balance between building and breaking down.
So I'll leave you with this thought. Knowing that your skeleton isn't some fixed object, but this incredible structure that is constantly renewing itself, what choices are you going to make today to take care of the skeleton you'll be living in 7 years from now?
And that concludes our Clinical Explainer. A huge, sincere thank you goes out to Assistant Professor Dr. Farhad Mustafa Musa Atrushi, MD, whose work was the entire foundation for this presentation. Thank you so much for joining us.